this video, we'll be looking at the last toolbox we'll be using in the sketch panel, which is the geometric constraint toolbox. Now, I have a lot of garbage on my screen here, and these are just going to be serving as quick examples of what all these geometric constraint buttons do. They're quite sophisticated. You could do a lot with them, but it requires some playing around to truly understand, just like all of this does. And in this video, we're just going to show a quick example of what they fundamentally do. Now, all of them are grouped together in this panel because they all provide logical constraints on a geometry. So an example of what I mean by a logical or geometric constraint is something that's not indicated by numbers, but instead indicated by an idea, like perpendicular or parallel. So let's look at the first button here with this first example. The first button here is coincidence, and what this button will do is make 2 points that were once separate, this one and the same point. So if we click on this button, and we have two lines that are clearly not connected, but we can connect them by clicking the endpoint of one and the endpoint of the other, and they become the same line. Moving on to the next geometric constraint, we have a collinear button. Collinear makes two things lie on the same line. So, if I click the first line and the second line, Inventor will adjust them so that they lie on the same path. Next, we have the concentric button. It makes two circles or arcs share the same center point. We have two circles here in which that is clearly not the case. They clearly do not share the same center, but if we use this tool and click on both circles, they now share the same center. The next tool is fixed. We're going to skip that one because it's not used too often, and you can find out a lot about it online. It's quite intuitive. It just keeps the selected geometry exactly how it is. The next one is the parallel constraint. So I have two lines here that are clearly not parallel. But if I use the parallel constraint and I select both lines, it makes them both parallel. Opposite to that is the perpendicular constraint. Selecting that and two lines that are clearly not perpendicular will make the lines perpendicular. Notice how it does not automatically make them coincident. That's something I'd have to do using different geometric constraints. If I wanted to make this vertical line coincident with the midpoint of this horizontal line, for example, I would click the end point of the vertical line and then just find the midpoint. Click there, and now I have perpendicular lines that are also coincident. After perpendicular, we have the horizontal constraints. Simply click on a line. Don't click on a point. You can click on the midpoint of the line. No, click on the actual line when it's all highlighted, and it makes a line that's not horizontal, horizontal. The opposite of that is the next tool, which is making a line vertical. Again, click on the line, don't click on a point. Okay, and Autodesk threw an error. This is interesting. You'd expect it just to make the line vertical. The error here is that the sketch is over-constrained. What that means is that there's already some constraint on this line that is preventing me from making this line vertical. So if we click on the line, we can see what constraints it has. And we see here there's a little symbol, and that's the same symbol up here as horizontal. So we can see we've already given this line a horizontal constraint. So, and if we want to make it vertical, we would be giving Inventor two conflicting commands. So we just want to right click and scroll down to delete constraints. Now if we click the vertical tool, we can make that line just the way we want it. Next is the tangent tool. You can make a line in a circle tangent to one another. again, notice how it does not make them coincident. If we wanted them to be coincident, we'd have to use other tools. It just makes the path of this line tangent to this circle. So if we did want them touching, we could draw a construction line to the edge of the circle. Use the coincident tool and select the midpoint of this line and the endpoint of the construction line we just drew, and now we have a coincident circle and tangent line pairing. Next, we're gonna skip the smooth and the symmetric constraints because they're not used too often, and we're gonna look at the equal constraint, making two lines or two circles have an equal radius or equal length. So here I have two lines, for example. If I click on both of them, it has made them of equal length. Just to show you, let's go up. We could do the same thing with two circles. It doesn't matter that they're sketch geometry, just an example. Click on the equal sign, click on both, and now they're the same size. Again, we can apply multiple geometric constraints. So if we wanted both of these to be horizontal equal lines, then we could first use our equal tool, select both. Now they're both equal in length. And if we make them both horizontal, we have a very different geometry than what we've just started. Now throughout this video you may have been wondering, well, it's changing one geometry to fit the other, but how does Inventor pick and choose which geometry it changes? The answer to that is it's pretty random by default, but there's absolutely a way around that. So let's zoom out and go over here. First, let's just look at this circle, and I'm going to use the concentric constraint, and let's see what happens. If I click on the small circle and the big circle, they're now concentric, and the small circle has moved its center to align with the big circles. But perhaps that's not what we wanted. Perhaps what we wanted was the big circle to move its center to correspond to the center of the small circle. We could force that to happen by giving the dimensions to the center of the small circle. And because it is now dimensioned, that center of that circle is fixed. And if we use the same exact tool, the concentric tool, and select both, we can see the big circle moved to fit the small circle. And at this point, we could always play around with these dimensions that we've given. Oh, sorry about that. At this point, we could always play around with those dimensions that we've given for the center of the small circle. Instead of 2.25 inches, this could be 3. But we can see they remain concentric, and it follows. And both centers of both circles are defined by these dimensions.